Hi guys, this is A2 Chemistry, Transition Elements, and we are looking at isomerism in complexes. Question 1. The ions of transition elements form complexes by reacting with ligand. State what is meant by the terms complex. So a complex is a molecule or ion consisting of a central transition metal ion surrounded by one or more ligands. So that is the definition of a complex. The next definition asked is that of a ligand. It is a molecule or an anion having lone pairs of electrons capable of forming dative covalent bonds with the transition metal ion. So this is the definition of a ligand. So ligands are of various types, but here we just need to put down the general definition of a ligand. Next, two of the complexes formed by copper are CuH2O6 2 positive and CuCl4 2 negative. Draw three-dimensional diagrams of the structures in the boxes and name their shapes. So copper surrounded by six water molecules forms an octahedral complex in which we would have a copper central metal ion forming a complex with six ligands and all six of them being water. So these are the positions for the binding of the water ligands, and the water ligands bind by forming dative covalent bonds with copper, and the oxygen atom in water is responsible for the formation of the dative covalent bond. So the oxygen will be bonded to copper, and we complete the complex by placing the H2 part of water. So this is how the ligands will be positioned, and in order to complete the complex, we make the square bracket of the complex and put 2 positive as the charge of the complex ion. The shape is also been asked, so the shape of this ion is octahedral. The next is copper chloride. Copper chloride has a central copper ion with a tetrahedral arrangement of ligands. So these are the positions where the four chloride ligands will bind to copper via dative covalent bonding. And since the overall charge is 2 negative, we make a square bracket to place this ion in and put 2 negative as the charge of the complex. And the shape of this complex is tetrahedral. Next, platinum forms square planar complexes in which all four ligands lie in the same plane as the platinum atom. There are two isomeric complexes with the formula PTNH3 twice and Cl twice. Suggest the structure of the two isomers, and by comparison with the similar type of isomerism in organic chemistry, suggest the type of isomerism shown here. So we have got square planar complexes being formed, which means that we have platinum as the central transition metal ion. We've got four positions of binding of ligands like this on both the ions, and the isomerism shown in these complexes is cis-trans isomerism. So in the cis isomer, we would have two chloride ions on adjacent positions attached to the platinum atom or ion in this case, and two ammonia on adjacent positions on the other side of the complex. So this complex is what is known as the cis isomer. In the trans isomer, we have two chloride ions placed diagonally opposite to each other on the platinum ion, and we've got ammonia diagonally opposite positioned on the platinum ion. So the cis and the trans isomers have been drawn. So there was type of isomerism. So this is cis trans, or it is also known as geometric isomerism for PTNH3 twice, Cl twice. Question 2. Cobalt 2 forms a 6 coordinate complex containing 3 water molecules and 3 chloride ions. Write the formula of the complex showing the overall charge if appropriate. So we have a cobalt ion with a charge of +2 attached to 3 water molecules, H2O thrice, and 3 chloride ions, Cl thrice. So the overall charge on this ion would be +2 and -3 gives us a charge of -1. So this ion will have a charge of -1. Next, they've asked, explain with the aid of diagrams how many isomers of complex in one exist. So they've asked for the number of isomers that exist for the complex with cobalt having 3 water and 3 chloride present as ligands. So we will have a cis and a trans isomer of this complex, and this would be octahedral as stated in the question, that it is a 6 coordinate complex, meaning it has octahedral arrangement, and the 6 ligands present show that there are 6 dative covalent bonds present in the complex. So these are the positions of binding of ligands on the complex. Next, we will add the ligands, 3 of each. We have 3 ligands that are water molecules and 3 ligands that are chloride ions. So on one of these isomers, we would have all 3 chlorides placed at adjacent positions and all 3 water molecules placed at the remaining positions. So this way we have made an one of the isomers which is known as the cis isomer of this complex. Now, in order to complete the shape of the complex, we place the square bracket and put a negative sign because it is having a net negative charge as we had already derived earlier. So, for the second ion, two of the chlorides will remain as they are, and one of the chlorides will be placed diagonally opposite to one of the chlorides placed already. And the remaining positions will be filled by water molecules as ligands, and this complex ion is the trans isomer of the complex. So they ask, explain the diagram how many isomers of complex in one exist. So these are two out of the three different isomers that can exist. Another isomer that exists for this ion is the optical isomer of the cis form of the complex. So we have an optical isomer as well. And in that optical isomer, it will be a non-superimposable mirror image of the cis isomer that had already been made. So this is the central transition metal ion. These are the positions of binding of the six ligands. Next, we will place the ligands in the positions which is a mirror image of the cis isomer that had already been formed. So the chloride at the top remains. The one on the diagonal left in the mirror image goes on the diagonal right, and the one at the bottom diagonal right goes on the diagonal left. So here the three chloride ions have been positioned in places that are mirror images of the one that had already been drawn, and the remaining positions will be filled by water molecules in order to complete the complex. And finally, the negative charge outside the square bracket of the complex completes the third isomer of the given complex. Question 3. There are two isomers with the formula NiR3P twice, I twice, but only one structure with the formula COR3P twice, I twice. R is the alkyl group and R3P is a monodentate ligand. Draw a diagram showing the structure of cobalt R3P twice, I twice, and the two isomers of nickel R3P twice, I twice. So, if we have a coordination number 4 in the complex and we've got isomers present, it means that their shape would be square planar and the isomers would be cis and trans. Whereas the complex that does not have any isomer present would be a tetrahedral complex. So let's begin with a tetrahedral complex. We have cobalt in the center with four positions for binding of ligands. So these are the four positions, and the ligands that bind are R3P at two positions and iodine or iodide ions at the remaining two positions. So this is the complex with cobalt. Now for the complex with nickel, we've got a cis and a trans conformation for this complex. The position of binding would be diagonally left and diagonally right as drawn. This is a 3D structure, but this is how it is represented in 2D when we draw the positions of the binding of ligands. So in the cis isomer, two ligands would be placed adjacent to one another, and in the trans isomer, those same two ligands would be placed diagonally opposite to one another. So here, the two ligands that are placed next to each other are iodide on this side and R3P on the opposite side. Whereas in the trans isomer, the iodides are placed diagonally opposite to one another, and R3P is also placed diagonally opposite to one another, completing the cis and the trans isomers of the given complex. Question 4. Only one structure of the complex NiR3P twice Cl twice is known. R is the alkyl group, or rather in this case methyl group, and R3P is a monodentate ligand. What does this indicate about the stereochemistry around the nickel atom? So since there is just one structure known, it does not have stereoisomers and it has a tetrahedral arrangement. Rather, its shape is tetrahedral. So, draw a three-dimensional diagram showing the structure of this complex. So, since it is a tetrahedral complex, we've got nickel in the center and four positions for binding of the ligands in 3D, and placing the ligands, we've got I chloride chloride, R3P and R3P. So the complex formed is a tetrahedral complex, hence it will not have any stereoisomers, whether it be cis trans or optical. Question 5. Nickel forms a complex ion NiEn thrice in which it is surrounded octahedral by 6 nitrogen atoms. Name the type of stereoisomerism displayed by NiEn thrice. Since there are 3 bidentate ligands attached to the nickel ion, the type of isomerism shown here would be optical. So they've asked us to draw 3-dimensional diagrams to show the 2 stereoisomers of NiEn thrice. So in order to do this, we would be needing the central nickel ion at 2 positions. Then we would be needing a mirror to show that these are optical isomers. Then we would be needing positions of binding of the ligands on both the ions forming the complex so that we can place the En molecules one by one, since En is a bidentate ligand. Also, they have said that all of them, all the positions or all the bonds are with the nitrogen atoms. So we need to show that nitrogen atoms have bonded to the nickel ion. So the first thing we'll do is define how we are going to display En. So for that, we are going to use a key. So En will be defined as N and N as a skeletal formula. En itself is actually H2N, CH2, CH2, and NH2, which can be defined as the skeletal formula. And now placing En on the 2 optical isomers. So color coding them, the red one, if placed here on one of the isomers, would be placed here as a mirror image on the other isomer. The next one would be color coded in olive green. So this is where they have been placed on one isomer. So the exact mirror image positions on the second isomer would be here. And color coding the third En molecule as blue places it here and here in the mirror image. Now, in order to complete the ion, we complete it by drawing the square brackets and placing the 2 positive sign on the outside of the square brackets. And here we can see the 2 optical isomers of Ni bonded to 3 En molecules.